Alright, let's go ahead and start this one up. If you have your train of thought, you think you can solve it, then, keep going by all means. So this is problem 30 from your textbook. In the picture, we have our weight, we're hanging it here. We want to know how far x is, right? How far x is to produce the equilibrium. This is allowed to slip. So it's just being held by friction here. It can slip. So if this goes too far, eventually it's going to cause it to fall down. Alright, so let's do it. So hopefully you've drawn this picture. Let's go ahead and draw in all our forces. We have this force, which is obvious, coming down, right? This is just going to be our W force. W. We have another W halfway. That's the bar. The bar itself has a weight of W. And then this distance, the whole bar, I think, was 4. Is that right?
Yep.
So since it's uniform, this would be 2. Alright, and then over here we have the tension coming at an angle. At this point, hopefully you're just kind of going to skip some steps, and we'll just call this Ty going up, Tx going this way. Then we have the wall itself. So the wall's pushing this way. We actually have a name for that. What's the name of the force from a wall? Normal. So we'll call that F normal. And then what's holding it up? Friction. So we'll call that F friction. So that should be our FBD, including all our locations. At this point now, we're just going to start doing our summations, right? Oops, where'd it go? Okay, let's do our summation. So it's kind of up to you, which one you want to do first. So let's do the torque one first, since we've been doing that. So again, you can choose your axis of rotation. For this particular problem, you should probably either choose point A or point B. Either of those would be okay, point A or point B. So let's do our sum of torque. I'm going to choose point A. So that's going to cancel out the frictional torque. We are going to have the weight. So that's going to be a clockwise torque. So we'll go W times X. Then we have the weight of the beam. That's going to produce a clockwise torque. That's going to be W times 2. Okay, then we have our Ty tension. That's going to be counterclockwise, so we'll set that equal. Okay, that should equal, well, Ty times 4. We can go ahead and fix Ty if we want. What's Ty going to be? T sine 37. So let's do that. So 4 times T sine 37. Alright. So we have 2 unknowns. So we're out of luck in like a direct solving here. We can't solve it directly because we have our 2, actually we have 3 unknowns, don't we? W, X, and T. Alright, let's do some more summations. Let's do X summation. Sum of Fx. Okay, this one should be very straightforward, right? For our sum of Xx, we have our normal force and our Tx. So we can just say Fn equals Tx. And actually, what is Tx? Okay, let's just get the number for this. What's someone want to cosine 37 me? 0.8, right? T. Okay, let's do our y summation. All right, our y summation, we do have 4 forces, right? So we have friction going up, we have Ty going up, so I'm going to just write it out as T sine 37, and then we have the 2 weights going down, so W plus W or 2W. So we just introduced a 4th unknown, didn't we? That's fun. So what can we do with that?
Which one? Force friction?
We have a 4th equation because we know the force of friction equation, right? What's the force of friction equation?
Mu times force.
So, by the way, this is the physics of the problem. Setting up these 3 equations. At this point, it's just going to be kind of a messy algebra problem. So let's just start doing some algebra. So mu is 0.5, correct? And Fn we found earlier. That was 0.8 times t. So we could write friction as 0.4 times t. Okay, let's just go ahead and substitute this into here. So we're going to have 0.4 times t plus sine 37 0.6 equals 2w. So what's 0.4t plus 0.6t? T, right? 1t. So t is equal to 2w. Now we're going to make one more substitution and solve this out. So we're going to throw t into that torque equation. Way at the top. So we're going to throw our t way up into here. Okay, so this is going to be w x plus w2 equals 4, and then that was 2t, right? No, 2w. Oops. 2w, and then sine 37 was 0.6. Okay, notice here we have w in all 3 terms. What can we do with that? Cancel out. W. X plus 2 equals 4 times 2, which is 8 times 6/10, 4.8. X equals 2.8.